Hey, let's take a look at page 2 of your assignment. We want to know on question 4, which are the ways you determine that a quadrilateral is a parallelogram? And there's more than one correct answer, or there can be. On choice L, the quadrilateral has 2 pairs of congruent angles. Nope, you have to have both pairs of opposite angles have to be congruent to be a parallelogram. Just because you have 2 pairs of congruent angles doesn't necessarily mean that that's going to be a parallelogram. Now, if we take a look at letter B, or N, I'm sorry, the quadrilateral has both pairs of opposite sides congruent. That's our definition. Okay, that if both pairs are congruent, then it's a parallelogram. The quadrilateral has one pair of opposite sides that are parallel and congruent. That's the weird one we talked about in the seminar. So that would work also. The quadrilateral has the diagonals that are different lengths. They can be different lengths, but that doesn't make it a parallelogram. The quadrilateral has both pairs of opposite angles congruent. There you have that one. Okay, on question number 5, if you got 2 parallelograms that have 4 congruent corresponding angles being congruent, are they going to be always be congruent, sometimes be congruent, or never be congruent? Well, if we've got both pairs of opposite sides, or well, 4 corresponding angles congruent, if I can get my pen here to work, they can be, because we can see that, but they also don't have to be. I'm not very good at drawing here, but they could be like different sizes. Okay, and so that would be sometimes. They would be congruent sometimes. And question number 6, if we take a look at that one, we're told ABCD is a parallelogram, and we're told AJ is congruent to KC. Show me that JBKD, show me the small one's a parallelogram. Well, remember, in a parallelogram, the diagonals bisect each other. So I'm going to draw in the big diagonal. I'm looking at ABCD. I draw in that big diagonal. Well, notice BD is a segment in my parallelogram. And so what I just marked there would be my midpoint. So that, I'll call this M. So I know A to M is congruent to M to C in my big parallelogram. And then, since M to C is the same, let me erase that line there, put that line in there. Well, that means that I would have J to M would have to be congruent to M to K if AM is congruent to MC. And so you've got both pairs of both pairs of diagonals bisect each other. That's the definition of a parallelogram. So JBKD is a parallelogram. Why? Because what we've shown here is we've shown that both pairs, well, geez, get my highlighter, keeps on showing up, okay? Both diagonals bisect each other. And since both diagonals bisect each other, that makes a parallelogram.